Well, hi, everybody. Welcome to the podcast. Our guest today is Professor John Grout. He is the former dean of the Campbell School of Business at Berry College in Rome, Georgia. He was recently a guest on My Favorite Mistake. That was episode 186. So I encourage you to go check that out. You can hear John's favorite mistake story and our conversation there. You can find it at markraven.com/mistake186. Or if you're not already listening to that, find My Favorite Mistake wherever you're listening to this podcast. And so I think it's going to be a different conversation here than we had in the last episode. A little bit of overlap, but I think a different conversation for a different audience. John and I, we collaborated on a Lean Enterprise Institute webinar that I was the host for. I think it was in 2010. I'm still trying to find out if that is online, if the recording of that is still available. There are some broken links that haven't been mistake-proofed, if you will. So I'm trying to follow up with the LEI folks, and if I get that sorted out, I'll put a link in the show notes. So before I tell you a little bit more about John, let me say first off, thank you for joining us. How are you?
Hi, Mark. I'm doing great. I hope you're doing well also.
Yeah, I'm excited about the conversation here. I guess, everything that was from that webinar in 2010, I'm sure it holds up, even if you or I or both of us barely remember that. That was so long ago.
Yeah, I actually think it's more relevant today and more importantly, more easier to implement today than it was back then.
So let's leave that as a teaser. We will come back to that question of whether mistake proofing concepts are easier to implement today and how so. So keep listening for that. But a little bit more about John Grout. He's currently the chair of the Technology, Entrepreneurship, and Data Analytics Department, and he is the David C. Garrett Jr. Professor of Business Administration. He's overseen the development, approval, and implementation of Berry College's Creative Technologies program and their makerspace called HackBerry Lab. John has researched mistake proofing extensively. He's published numerous articles on mistake proofing. In 2004, he received the Shingo Prize for his paper, The Human Side of Mistake Proofing, that was authored with Douglas Stewart. He's also consulted with a large variety of businesses to help mistake proof their processes. And he's published, there's a free ebook that's available online through the AHRQ. It's Mistake Proofing the Design of Healthcare Processes. So I encourage, if you're working in healthcare or otherwise, go grab a copy of that. That's still available online. And John's website is mistakeproofing.com. That healthcare ebook is still available to your knowledge, right?
Yes, it is. It is absolutely still out on the web. And I also have a PDF copy on my hard drive if anyone can't get it any other way.
So I hope people will go check that out. And there's probably a lot to offer for a reader that's not working in healthcare in terms of looking for different ideas that help them think about their own mistake proofing. Would you agree with that?
I would agree with that. The framework is set up to use a whole bunch of existing quality management and reliability modeling tools to help you think through how to create mistake proofing devices, environments where you're not sure exactly what you should be doing. So I think one of the fallacies that we sometimes see is that we assume that, the saying is that, a problem well defined is half solved. Mm-hmm. And, that's probably true, but there are those cases where you see something happening and you don't really have a good vocabulary of how to fix it. Mm-hmm. And this book will provide that vocabulary.
Yeah, so I hope people will check that out. And again, there's a link in the show notes, and you can find it on John's website, mistakeproofing.com. So John, there's one question. It's become a habit, I guess, recently of asking different guests, their origin story, if you will. Like, how did you first learn about mistake proofing? Was it in a broader context of learning about Lean or the Toyota production system? I'm curious, what was your initial introduction, and what sparked a really deep focus in this?
So back in 1991, I was teaching at Southern Methodist University, and they were in the middle of the TQM furor. And they asked me to teach a quality course. Now, I had had lots of statistical quality control training, both in my undergrad and grad programs, but I wanted to do a thorough read through of everything that was out there. And as I was looking through it, it seems like Schoenberger had said something. He was one of the very early writers on the lean side. And he had mentioned poka-yoke. And so I was interested in, what it was, just to know whether it should go in the course or not. And I found it very difficult to find anything about poka-yoke. And I finally stumbled on Shingo's book, ordered it, had it sent in, and read it. And it is not kind to statistical quality control.
Shingo's book.
Yeah. He kind of says statistical quality control has all these problems, and here are the issues. And I was about to teach this stuff. And so I had to sort out who was right. And I have done that to my satisfaction and have published academic journal articles based on that. And I now do a lot of mistake proofing, but I still think Shingo might have gotten a few things wrong.
So I was going to ask you to elaborate on that. I mean, first off, for people who might not know the terminology, how would you summarize, first off, statistical quality control?
So my view of statistical quality control is you have acceptance sampling on one side, and I think by and large people have figured out that that doesn't really help the core of the problem. All it does is keep product out of your factory, maybe. The other is statistical process control, which involves control charts and 3 standard deviation limits above and below the mean. And when you have unusual products, things that go outside those limits, you need to find out what's going on and take action. Now, in terms of Shingo's mistake, I think his main mistake was he inferred that every time you had a defect, you were out of control, or that a remedial action was required every time you have a defect. And I think that the whole notion of process capability is the idea that if you can't consistently kick your field goal through the goalposts, that you have to work on the variance. You can't just take one-off things and adjust based on individual defects. You have to manage the entire process. And if you have a process that's in control and you make adjustments based on individual defects, you may be making the process worse.
Tampering, if you will, was the term
Tampering.
Deming and
Exactly.
others used, over-adjusting a process. Yeah.
And so Shingo didn't kind of focus on that aspect, and so kind of blurred control limits and process limits. That is, control limits and tolerance limits, or specification limits.
Right.
And so he was conflating the engineering limit of this will function, this won't, with the statistical limit of this is usual, this is unusual.
And I think we can keep diving into this topic of is mistake proofing a binary in spec or out of spec sort of determination versus the idea that I think would come from SQC and SPC, that being closer to the center line of your specifications and tightening the variation would be better, where a lot of mistake, I think of physical mistake proofing of a product flowing down a line, and if the product is too big, it bumps some sort of barrier and gets kicked to the side. It's a go, no-go gauge in that case, but that might not really be the best we can do from a quality perspective, right?
Right. And so I think it's worthwhile to have defects not make it to the customer, because the cost of that is almost always way higher. And so Shingo had a variety of different inspection techniques. He talked about successive checks and self-checks. Successive checks is when a downstream operation runs your product through a go, no-go gauge. Your self-checks are when you do it. And of course, it's always better if you do it than if someone else does it. But then he had something called source inspections. And I think that's really his kind of gold standard concept, which is that you need to inspect the conditions that will lead to high quality and make sure those exist before you produce the product.
Mhm.
And it's also where it fits very nicely with statistical process control. Because if you have an out of control point, it's saying something unusual has happened, and your job is to go into the process, understand it, explore it, do experiments, whatever's required to find out why you had that out of control point. Once you find out why, you need to take that precondition for good product and test that precondition, and a source inspection is how you do that.
And source inspection would be, in the case of a manufacturer, back at the supplier or on receipt into your factory?
So I think you're focusing on the product. And what I recommend is that we focus on the process. And so we're going to look at a process and say, is the temperature right? Or is the machine setup correct? Or is the, if something comes out of calibration, is there a way for the device itself to say, yo, I'm out of calibration?
Yeah.
So we want the process to talk to us, and source inspection is how we get it to do that. And typically it's done with very simple kinds of means to make it obvious that something's going wrong before it causes a problem.
Yeah. And there's, SPC, I saw this, you're judging up memories from my first year, especially at General Motors, 1995, executives confusing the difference between the control limits on the SPC chart, which are calculated based on process and how much variation there was. And then that would be part of the input into the process capability calculation, but they would confuse specification limits with control limits, I think, to great detriment. So, the very real scenario here, I'm curious how you would react or coach somebody on it. So you've got somebody on, frontline production worker is doing their SPC checks, and they notice, hey, something has drifted above the upper limit. We should stop and do something. Management says, well, it's in spec. The part's good. Why the hell would we stop production?
I think the answer there is that you would stop production, or, I am not dogmatic about stopping production. What I think you would do is go figure out what's going on with the machine. Why did it go above the limits? And try and resolve that issue without ever making a defect. So, at some level, I know maybe the orthodoxy is you stop the machine, but if you can figure it out without stopping the machine, then you've got it's sort of like internal and external setup. You would love to figure it out while the machine is running. But if you can't, I think that there's a benefit to be had by stopping the machine long enough to see if you can figure out what that special cause is. And then work out a system for inspecting for that special cause as a source inspection using Pokio.
And thank you. Yeah, that's a good nuance there. If the point is protecting the customer and doing that investigation versus not doing the investigation, like the process we were working on was, I'm thinking of a machining line where this is where memories and technical details were either fuzzy or never fully understood. But a lot of times the debate was being framed in terms of, do we keep producing or not? I don't think that middle ground was being explored necessarily, and that could be a different problem.
We having knee-jerk reactions is so easy in life. And in some ways, that's what statistical process control is all about. Don't adjust the process unless you have something that's out of control. And we all want to say, oh, that's a defect, let's fix it. And what SPC says is if it's just generic, normal process variation, fixing it does not involve adjusting it based on a single defect.
Yeah. Or adjusting it based on, I mean, I think the worst form of tampering, and this goes back to Deming and the funnel experiment of saying, well, this part, this hole in the engine block is larger than the center line of the spec. So let's tweak the machine and try to make the next one a little bit smaller. And then, that really amplifies variation in a really bad way.
Exactly.
But I think back to field goals for a minute, and I could bring at some point a friend of mine who does a lot of Lean Six Sigma work, and he was a guest on My Favorite Mistake, Brian Hurley. He was a place kicker at the University of Iowa on their football team.
So he understands process capability very well.
Well, this is where I would be curious to pull him into the discussion, because a field goal anywhere between those goalposts, even if it hits the goalpost and still goes through, is worth the same 3 points.
Yeah.
So there's that go, no go, good, not good kind of binary. The kick was in the result of the kick was in spec or not. But I'd be curious, back to your point of source inspection, to see if this analogy is a way of thinking through it. Source inspection on the kicker might look at their mechanics and like the leg angle or different things of saying, well, if the leg angle is more consistent, then the kicks are more likely to be good. Is that?
Yeah. And so in some ways, I don't know if it's necessarily, some of the things that you would call a source inspection don't look a lot like an inspection.
Mm-hmm.
So for example, if you have a kicker and he has practiced, and what he knows is that he lines up his shot, he steps back 3 steps, but then he'll step sideways 2 steps.
Sure.
The 2 steps sideways are his effort to get the right angle of approach to get the ball to go where he wants it to go. And so he's built into the process a way of determining where the starting place ought to be.
Mm-hmm.
From my perspective, that really borders on a source inspection.
Mm-hmm.
I would be hard if they said, "Oh, that's a source inspection." I would be hard pressed to say, "Oh, no, it's not."
Mm-hmm.
I think it's really close. And so, source inspection. Sometimes inspection's not a great word for it,
Mm-hmm.
because it's just, in some ways it's good management, and it doesn't have to be sophisticated. It doesn't have to be based on some computer-aided anything. It could be always taking 2 steps
Mm-hmm.
to the right. I put my parking ticket when I go to the airport
Mm-hmm.
in my wallet. And the reason I do that is it means I can't leave my car without knowing I've got my wallet in my pocket.
Right.
And, you get into the airport, you don't have your wallet, you're not going anywhere.
Right.
And so
If you have a passport in your bag, but I get your point. Right. Yeah.
It's procedural.
Right.
And so calling it an inspection probably is stretching things a little. And yet I think that's what Shingo has in mind.
And it sounds more like maybe in TPS speak, going to the Gemba, understanding your process and the connection between process and results. Absolutely.
And mistake proofing, and particularly source inspection, tends to be very, very idiosyncratic. It's precise to your particular process, which is why, when people would pay me money to come and talk to them about mistake proofing, they would say, well, how do we mistake proof this? And I said, well, I don't know, because I don't have any of the detailed knowledge that's necessary to design a really good mistake proofing device. That's why I wrote a book like the mistake proofing, the design of healthcare processes. It was because I wanted to give what I knew to them, because they had all the detailed knowledge to actually implement it.
Yeah. So let me come back to healthcare in a minute, because that's the more meaningful, life-changing, implications and application of this. But just, one of the things just to think about kicking for a minute, those 2 steps, there's probably this question of how consistent are those steps?
Mhm.
right? If I 2 steps is not always the same. So how do you train yourself, even if the wind is blowing really hard, that those 2 steps are the same size would
Yeah.
probably be an indicator of quality.
Yeah. Um, so that's a kind of a meta question to me.
Mhm.
A question above the question. Um, I think that, in their case, they don't get to take a measuring tape out on the field.
No, no.
Um, although I don't know that that's ever been tested, but
Well, there was something that happened recently in an NFL game. What was illegal and what was a penalty was it was a wet field and they brought a towel. I'm pretty sure it was an NFL game. They brought a towel out onto the field and the holder was kind of trying to dry the part of the field where the kick was going to be placed, and that was penalized. So a tape measure,
really,
even had the time, that might also be considered somehow in. But they said that the towel was interfering with the field. The tape measure isn't changing the field. So I don't know.
yeah, that's a conjecture. I'm not sure I care if we actually experience or not. But,
Sure.
I think every time he practices, one of the things he's practicing is how wide are those steps. And hopefully he gets it to the place where it's muscle memory. And as long as he can get the game circumstances out of his head, which is the hard part of kicking anyway,
Yeah.
he can take those 2 steps, he's ready to go, and he kicks it. Or it may be that the variability of his steps is small enough that it doesn't impact his CPK, that, his process capabilities are just fine, even if he takes a big step versus a small step, because the posts are quite a ways apart.
Yeah. Well, you say, you talk about muscle memory. I have, I've probably only tried kicking a football like that once, and it was not in any sort of game setting. It was just being out on the field. But I think of during a marching band rehearsal, because I was in the marching band for 8 years in high school and college. So there's a point where you talk about the distance of your steps. Traditional marching band, I won't spend too much time on this, I swear. 8 steps every 5 yards. So that's 22 and a half inches per step. And you want each of those steps to be the same because of the quality in the dimension of quality of how the band looks when you're marching, how straight
everything lines up
are your lines. And the ideal would be that every step is 22 and a half inches. So a line is continually looking perfectly aligned. But that quality check is that you can kind of peek down and you're not supposed to move your head down. There's another visual thing. But if the ball of your foot is hitting that yard line, which are thankfully marked off every 5 yards, you can gauge how you're doing. Now, you don't want to be taking a bunch of small steps and make up for it with one big step at the end. But that muscle memory actually becomes quite good where you can test it by closing your eyes, marching 10 yards. And boy, if your right foot ended up right on that yard line, then you got it dialed in.
It's remarkable what the human body can do very consistently. And yet that's also the cause of the problem with mistake proofing. One of the reasons mistake proofing is hard is because people don't make mistakes very often. But when they do, it can be catastrophic. And so it puts it outside the realm of normal statistics, because statistics are not good at rare events. And that's what human mistakes are all about, is the rare event. Human beings as a process is very reliable. 1 in 1,000, 1 in 10,000. We get things right all the time. It's just that 1 in 1,000 times that it's a problem. And so that's why when you design your mistake proofing device, you're thinking about those kinds of issues and triggering when those have happened and stopping the process right then.
Yeah. So, okay, I'm going to put football field behind us now. Let's think a little bit more about operating room, even before we get into definitions here. So, I think about healthcare rare events. Let's say you're the patient, and the surgeon operates on the wrong side or the wrong site. I don't know the exact numbers, but that happens very rarely, and we're not going to fall back on, well, on average, they're getting it right, because the impact when they don't is huge.
Nor is it subject to any kind of normal statistical process control.
Right. There's not a bell curve of how wrong are they. It's either, it's right or wrong.
Yeah.
So do you have thoughts or experiences around, and I realize this is probably a very complex thing to try to error proof, but if the problem statement is that rare mistake of the wrong side or wrong site, what would part of your thought process be about how to try to error proof that?
Well, I think that a lot has been done using something that they call the universal protocol, which is to sign your site. So if you're having surgery on your left arm, they should be explaining to you the procedure well enough and then asking you to write your name where the cut's going to occur. I've also heard people say that they write no on the other arm. That doesn't help at all. And the reason it doesn't help at all is because then if they drape you for an appendectomy, you're out of luck.
Right.
Because no one will, it presumes that you're on one of the two arms. And sometimes the wrong site is an entirely wrong surgery.
Yeah, it's not a bilateral, it's a difference. It's the wrong surgery.
And over time, if the surgeon knows I'm only going to cut if I'm cutting through the person's signature, that's a pretty decent signal.
Yeah.
And when you add to that the timeout where the entire surgical team stops for a minute and says, okay, let's all agree about what we're doing here. We're operating on the left arm below the elbow, and we're doing this procedure. Here's how it's going to work. Here's about how long it's going to last. And even things like, do they introduce each other around the room so that everybody knows everybody else, or at least has some sense of who they are? Right. And then they all look at the site and there's a signature there, that's a step in the right direction.
Yeah.
Is it a perfect mistake proofing device? I have yet to figure out a perfect mistake proofing device for that particular application.
Yeah. It seems like a lot of that is dependent on our ability or our willingness, it's probably the better word, our willingness to follow the quote unquote universal protocol.
Right.
Do we have data on how often that's really occurring or not occurring?
There probably is data, but I don't have that data.
I mean, my little bit of exposure to operating rooms is I have a question, where's that data coming from? Yeah. It's certainly not being universally tracked.
No.
In a really reliable data sort of way.
In fact, my wife was in for some surgery, and I asked the nurse about a timeout procedure, and she says, "Oh, they always clean the room thoroughly between operations." And I'm like, that's terrible. That is not the answer.
Right.
And the anesthesiologist, I said, so in this particular case, because this was internal surgery that was female surgery, so there was no kind of external body incision going on. And so I said, so how does the universal protocol work in a case like this? And I forget what he said, but it was like he totally whiffed on the answer. He just came nowhere close to understanding that I was saying, in a case where the site isn't an external incision, what do you do then to make sure you're doing the right operation? And he had no idea. One of my students in an evening MBA class was the chief operating officer of this hospital. So I sat down and typed out an email in the waiting room and sent it to him and said, I just want this date and time stamped that you've got these issues. Mm-hmm. And it's making me nervous. Now, surgery went off fine, no problems. Mm-hmm. But, my view was, I want to be on record that this is not what I had in mind. And I ended up on the quality board for that hospital years later. And they're like, oh, I recounted the story. And they're like, oh, you're the guy. And to their credit, their quality culture was such that story still remained in active memory to the people I was talking to, mm-hmm. like 5-10 years later.
Yeah.
And that I admire.
And this is all, I mean, you touch on culture and behavior, and there's, I'm sure, elements of psychology. This becomes a fairly complex thing as opposed to the physical size of a part that we've been cutting. back in a factory. So kind of recap, and I've seen it go both ways. I had a friend of mine send a picture where somebody I used to work with. She was a Six Sigma black belt. Her husband had a broken collarbone, and they sent a picture where they had written no on the non-broken collarbone. Well, it was painfully obvious, painful to him. Like you could obviously visually see that's the broken one. And they thought, well, okay, thank you for following the protocol, because you don't want to be in a situation of like, well, we don't need it this time. But to your point, like you could write no on an almost infinite number of body parts instead of marking the one spot, right?
Right. And at the start of all of this, 1 in 4 orthopedic surgeons would have a wrong site surgery during their career.
Mm-hmm.
So that's rare, but not nearly rare enough.
Right. And there's, so, again, on soapbox for a minute, universal protocol, I think of it as so-called universal protocol, like universal is the ideal. And
it ought to be done every time.
Ought to be. And hopefully the right form of it, because there would be variation around you signing the spot versus the doctor signing it. Now, if I'm having back surgery, I probably can't literally write on my lower back, but I could see where it would introduce opportunities for error if the doctor is signing it. And let's say you've already been given some medication that makes you drowsy.
Right.
If the x-ray's been flipped and they mark the left arm and you're barely aware of it, that could lead to a mistake.
Absolutely. And that would not be the universal protocol.
Right.
And in some ways, far better to have a loved one, like you would say to your wife, okay, I can point to it. I just can't write my name there.
Yeah.
Put it right here. To me, that would be better.
Yeah. So, the universal protocol is supposed to help prevent one form. There's this terminology that, again, I think is sort of ideal or optimistic never events. I definitely refer to these as so-called never events because they happen. Like never is not. I mean, that's the goal. It's not the reality.
Right. It's like 0 defects.
So tell me, and for those who are listening and not watching on YouTube, I'm quite intentionally wearing a hat that says 0. That is a reference to zero harm from the Patient Safety Movement Foundation. John noticed this, of course, when we got on. So I was going to ask you your thoughts on this idea of aiming for 0, talking about 0.
I think it's the only way to go. I think it makes perfect sense to aim for 0. And in all of these cases, if a customer gets a defect, that's a problem. 1 defect is a problem. And so 0 should be the target. Mm-hmm. Now, getting there, it all depends what environment you're working in and what kind of knobs and tools and dials that you can turn to make things better. One of the things I love, back in the old days, I guess it was Crosby said that quality is free. And his argument was that the cost of preventing defects was always less than the cost of the defects. And I think through the years, people have just kind of stopped arguing about it.
I argued with, or not just I, some of my classmates in grad school at MIT that had a background in manufacturing. We actually did end up arguing with a microeconomics professor who really was still teaching this idea of, the optimal quality levels and these assumed trade-offs that better quality costs more, and at some point it ain't worth it. And we're like, but that trade-off isn't true. And he basically, I remember he got to a point where he was like, okay, you all need to shut up so I can finish my lecture. Like it was a little more polite. But we did talk about it after the fact because we were hoping to try to educate him from what we were seeing in industry. And he was still pretty upset that we were kind of derailing his lecture.
Well, I think the issue is that if you look at it from a statistical perspective, if you're on a normal curve, and if it really is infinite tails, it's hard to get to 0 when it's an infinite tail.
Sure.
It's also hard if you've got that infinite tail driving the prevention and appraisal part of the old concept of cost of quality. But then you look at mistake proofing and you say, okay, can we virtually eliminate a mistake at a finite cost that's reasonable, that's not too expensive? And the answer is, of course you can. And we've got lots of examples where people have done things and the errors have gone away. Mm-hmm. Like, until you have a different process, that error is not going to occur again.
Yeah.
And it's done using, a pin or a piece of steel sticking up, or a little sensor. Now, with the sensor, you do add on some appraisal costs because you've got to keep it calibrated. Mm-hmm. But as long as you keep it calibrated, it's going to do what it's supposed to do. And so, I'm of a mixed mind on zero defects as a practical kind of theoretical matter, mm-hmm. but as a practical everyday matter, it's clearly the right target.
Yeah, and I think in relatively simple error-proofing applications, you really can reach zero defects. So, like a simple go no go gauge as parts are flowing down a line, you could say, unless the error proofing device failed somehow, that would be perfect,
right?
Mistake proofing. But then you get into more complex systems, and coming back to Toyota, as much as they talk about quality at the source, and going back to Shingo and long practice of mistake proofing. 2019, the last opportunities I had to go to a Toyota plant in Japan, they have final inspection, and that might be surprising to some people. Of like, well, why? I thought inspection was waste. Like, if we're going to be dogmatic, and Toyota, I think, is decidedly not dogmatic on things like this.
Yeah, I've often thought that would be an interesting research paper to write, which is, when is the optimal time to stop inspecting?
Mm-hmm.
And it seems to me a challenging question to answer.
Yeah.
You have to make some presumptions about the process that are difficult to make.
Because you could err, you could keep doing final inspection well beyond the time it's necessary. But, and this is a story I've told before, I think in other episodes, 1995 General Motors, there was a design intent for the engine factory that quality was going to be built in. Mm-hmm. And they decided to eliminate they used to do a hot test at the end of engine assembly. Fire up the engine, make sure it's working fine. And there was sort of like this dogmatic of like, well, we don't need that anymore because we're building quality in. So then, unfortunately, that first hot test was happening after the engine was installed in a Cadillac. And at the end of the Cadillac assembly line, they would go to fire up the engine to drive it off the line. And going back to the engine block machining, if there was some part where the hole was too big, and now this engine is literally got black smoke coming out of it, all the potentially defective engines between there all the way back to machining could have been like 2,000 bad parts and hundreds of assembled engines, 100 already installed in cars. Like, that was the mistake of ending inspection too soon.
And it's a presumption that that entropy doesn't happen. Mm-hmm. And entropy is one of those laws you can't get away from. I've got another example of that. Frito-Lay was, this would have been back in the 90s, so it's a long time ago. But they had their tortilla chip production down to a science. Mm-hmm. And they started doing everything associated with the science of getting that chip right. And they started losing taste tests, blind taste tests, to Eagle Brand, which was a brand back then. Mm-hmm. And Eagle Brand was winning in the taste tests for blind taste tests. Now, if it was branded, people still liked Frito-Lay better, but if it was unbranded and they couldn't tell, they liked the Eagle Brand better. And Frito-Lay, to their credit, said, we can't have this. This is not acceptable. And so they realized that no one was tasting the chips.
Yeah.
And they found out that you need to have a person on the line producing chips, tasting the chips. Mm-hmm. So it's that final inspection. And so they hired an artist, and they made a chip that was a little raw, one that was just right, a little one that was a little cooked too much. They're interested in the amount of blister on the chip. It was amazing stuff.
Yeah.
We would never care about that, but they cared about it. And that's why the chips turned out good. And so they would hold the chip up and they would, look at the chip and say, which model does it look like? And then they would eat the chip. And then they had a bag of gold standard chips. And they would eat the gold standard chip and say, does it taste like that? And it's like, oh yeah, those taste about the same. Yeah. And they had a whole procedure to keep a gold standard bag in stock.
Right.
Because you had to rotate it through. You couldn't let it sit there for 2 weeks because then it wasn't a gold standard chip.
It's stale now. Yeah.
Yeah.
So someone's deciding what's the gold standard and how accurate are they in deciding that?
Yeah. And so through time, if that gold standard gets messed up, yeah, you could have problems. But, they did their best. And at some level, it still depends on someone eating the chip and going, oh, yeah, that tastes okay.
Yeah.
And I'm sure there are people with more refined palates than mine who could do that well.
And that's where it comes back to how do we define quality? We could be looking at process measures or variables that really don't matter to the customer. We might think we're really dialing it in on quality in a way that is really pretty meaningless to the business.
Yeah. Yeah. So Frito-Lay wanted 15% broken chips or less. Once my kid picks up the bag off the shelf and jams it in the cart, that metric is out the window.
I mean, it sounds like the old story that may or may not be true of the Japanese supplier getting an order from the American automaker, and the punchline of the story in this case would be, here's your bags full of broken chips that you wanted,
Yeah. 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 We separated out the 15%. They're here. The rest of them are fine.
Yeah. Right.
Yeah. And that goes back to a name that is really going back to Gucci.
Mm-hmm.
And the whole idea that any variance is worse than, that any amount of variance should be reduced. And I haven't heard his name in forever, but I think his idea is still true, that if you can get variance as low as possible, that you're better off, even if it functions just as well with higher variance.
This is the Taguchi loss function. And if Taguchi invented football, and I've actually drew a chart like this once where a Taguchi football game nowadays would have some sort of laser measurement, and the points on a field goal would be determined based on how close it was to the center of the goalpost. You would get maybe 4 points for a kick that was perfectly centered, all the way down to a half point if you barely missed the upright.
Yeah, you can have a little post sticking up, and whichever one you knocked off as it went through would.
I jumped to technology. There could be a bunch of pool noodles or something going across.
Which is instructive in terms of mistake proofing, because it's so easy to think you've got to have a laser to do it. And you don't. Sometimes it's a pin on a die that keeps you from putting the part in backwards. Mm-hmm. Some of the best mistake proofing I've ever seen are these devices that are $25 or less. And in Shingo's book, of course, nowadays that would be a $50 part because of inflation. But, he had about a quarter of his ideas were $25 or less. And fully half of them were $100 or less back then. So that would be $200 now, $250. But would anybody pay $250 to eliminate a mode of defect in their factory? I'm guessing lots of people would sign up for that.
So then you mentioned earlier, let's come back to the thing that we teased early on, where you're saying compared to 2010, it's easier to mistake proof things today. Is that because of technology, or why is that?
Oh yeah, it's absolutely because of technology. And I was actually thinking more like, the heyday for mistake proofing was 95 to 2000. That's when, there were, conferences about Poka-yoke. There's no conference about Poka-yoke anymore. And yet now more than ever is the time to do it, because now you can get, so with the maker movement came this thing called an Arduino. It's a little programmable logic controller that costs $35. And once you've got it sorted out, you can buy an Arduino Mini for $10. And you can hook it to a limit switch or to a light sensor or to any number of different kinds of sensors, a Hall sensor that will do magnetic. And I've got undergrads in their first semester doing prototypes where they can do basic programmable logic controller mistake proofing.
Yeah.
And, you couldn't do that in 2000. Back then, you had to, figure out how to do it on an ABB or a Square D or, one of these industrial programmable logic controllers that were hundreds of dollars. And now it's a $10 thing. It's so easy.
So it makes me wonder, back in 1999, 2000, when I was working at Dell Computer, one of the parts of the process is what they call the pick to light line, where based on that order for those computers, people would pick the different parts, the hard drive and fan and different things that would go into a kit that was then sent down to the assembly station. And I'm trying to remember exactly how it worked. Like, one version of pick to light would be lights that say, here are the ones you grab. I'm pretty sure they had some error proofing where if you tried to grab the wrong one, there would be some sort of indicator or a light or a buzzer or something.
Yeah. And there was a company called Speeds Tech back in the day that had one that had a laser, kind of not a laser, a
light curtain, maybe.
Yeah, a light curtain.
Right. Yeah.
And it would cycle around, and if you stuck your hand in the right spot, it would turn the light off. If you stuck your hand in anywhere else, it would say that's the wrong spot, and a buzzer would go off. They had good luck with it. They were down to their pick went from like 200 parts per million down to 2.
Yeah.
And by the way, that's the hardest mile in all of this, is going from 200 parts per million, which is fantastic, to 2, which is world class.
Yeah. So then I bet that technology would be a lot cheaper today, is what you're saying.
Oh, yeah. I've got undergrads who could do that all day long.
Yeah. But then I think of this is
so
also
to put this in perspective.
Yeah.
I had an undergrad who, for his senior project, created a vision system to look at a box with fuses in it. So, the automotive fuses with the number printed on top. He had 5 of those in a row that was going into, I think it was don't quote me on this, I think it was a Kubota tractor. And so they had this wiring harness, and the fuses would get put into the wrong place. He created on his own a vision system to look at those, do optical character recognition, and figure out whether they were in the right spot based on the spec, and alert the operator if they were in the wrong place. And it then took a picture of it, so that if the company ever came back to this vendor and said, the fuses were in the wrong spot, you go, here's the picture. They came out of the factory correct. And so he had both the quality at the source, and he had nice audit documentation.
Yeah. And, it's making me reflect on, like, going back to 1999 Dell Computer, like, the impact was pretty trivial if there was a mistake in the pick to light line, because then in the assembly station, there was further error proofing where, if I remember right, pretty much everything was barcoded and everything was scanned. And to the order, if there was a part missing or the wrong part, that would get caught, and that would lead to a little bit of inefficiency, but it would probably protect the customer. And sure, you would want to prevent the waste of having to go swap out, chase down the right part, versus the lack of error proofing in a process as critical as, let's say, gathering the right instruments for a surgery, where then if it's discovered once the patient has been under anesthesia, and it's supposed to be detected in advance, right? But the defect of, let's say, a missing instrument could be discovered at a point where now it either delays a surgical procedure, which could have an impact on the patient, depending on the situation. They could find the error once they're under anesthesia, which is bad because now they're under anesthesia longer, or the error could be found once they've already been cut open, when that's even worse. And there's, I hate to say it, there's a lack of error proofing in that operation.
Oh, absolutely. And all of a sudden, your inventory theory becomes part of your quality management system. And so, of course, the fix for that is to have prepackaged kits.
And sometimes you can do that depending on the procedure.
Right, but not all procedures are that way, and not all doctors like what the kit has in it.
Well, and if the kit was perfect when it first comes in, The challenge then at the end of the procedure is if you've opened up 4 trays, who's guaranteeing that the right instruments go back into the right tray? That's part of the waste in the process of processing and then sterilizing those instruments, is kind of sorting out the mess that was created back upstream in the operating room.
Well, yeah. And in many cases, they're designed with disposable product.
And that's true sometimes too.
Of course, then you've got the hazardous waste that comes from it.
Mm-hmm.
So, all of these are trade-offs.
Yeah.
And so
there are some other things that are hard to error-proof in that context, where one defect could be the instruments getting back to the operating room, and there appears to be what they politely call bioburden, kind of euphemism of it's supposed to be inspected. It's certainly not error-proofed, but there are all sorts of back to your idea of source inspection, and it's kind of an interesting value stream in that it's circular, where you could go back to look at the process, and I was part of a team that did this back in the operating room. If the instruments aren't properly sprayed with a foam, then the odds of properly cleaning and sterilizing them in the sterile processing department goes down dramatically. So it comes back to hey, your process helps us help you, but how do you do those process checks rather than just doing inspection at the end?
Yeah. So well, one of the things I want your listeners to understand is that mistake proofing is not easy.
Mm-hmm.
And designing good mistake proofing devices is the pinnacle of design. The idea that you make something that is essentially invisible until it's needed.
Mm-hmm.
Back in the day when you had a 3.5-inch disc and you put it in the machine correctly, no problem. You put it in upside down, it stops you halfway in.
Yeah.
It only notifies you when something's wrong. The rest of the time, you may not even know it's there. I have a table saw like that. It's a saw stop table saw. And until I touch it with my finger, it's going to be just fine. I'm not going to know that it's any different than any other saw.
Yeah.
As soon as I touch the spinning blade with my finger, it snaps out of the way.
Yeah.
I have a little cut on my finger. I put a Band-Aid on it and I'm done.
Yeah.
And so, and people said, oh, that's no good. Particularly the other manufacturers, they didn't want to use the technology. And now it's the top selling saw in the market.
I wonder if they're thinking of well, clearly that's user error and you shouldn't put your finger or any body part anywhere near the saw. There's back to some psychology of blaming the user or blaming them for being human, because we all get inattentive or sloppy at times.
Well, I think what was really going on was that the owner of SawStop, or the inventor of SawStop, is a patent lawyer.
Yeah.
He had patented it and he was trying to license it. He didn't want to build saws at all, but when no one else, they could see that they were going to be paying him royalties for the rest of their lives, and they didn't want to go down that road. And he didn't want to build saws, but he was essentially forced to. So he went and found a contract manufacturer. They built a saw. It's sold like hotcakes. And to this day, all of the other power tool makers are like, yeah, no, don't do that.
Yeah. It's like competitive disadvantage to them.
And, because he knows how to play the game, he went to the National Product Safety Commission and tried to get rulings that would force everyone else to buy his module for their saws. And as far as I know, that didn't end up succeeding.
So a quick detour, but you mentioned this National Product Safety Commission. We have a National Transportation Safety Board.
Mm-hmm.
There are people advocating that we need something, they're calling it the National Patient Safety Board. It seems like it's interesting that there's a societal or legal role and a place for commissions or boards like that, but we don't have that in healthcare.
Yeah. And so one of the things that we have found out about mistakes is that people don't like to own up to them.
Mm-hmm.
And in particular, they don't like to own up to them if they're going to be fired as a result.
Right.
Or sanctioned or punished or what have you.
Right.
And so there's this whole other realm called just culture.
Right.
And just culture is where you figure out a way to do a full and thorough investigation without people feeling threatened. And yet you want accountability. If someone's been egregiously
willfully harmful,
right, those people should be held accountable. And so sorting out how to draw that line has been something that there's been a lot of talk about. Now, National Traffic Safety Board does that because you report if you see another plane that's doing something unsafe, or you're in a plane as a pilot who's doing something that's unsafe, you can report it. I'm trying to remember how that works, but there's an offshoot of NASA, and I think it may be the national. I think it may be the NTSB.
But there's this non-punitive reporting.
Right. So there's a no-fault reporting and there's a fault reporting. So the FAA will come after you, but the NTSB won't, or something like that. I'm not sure I've got the agencies correct there. Sure. But the idea is that you can get a full report of near misses and actual events and learn from those without having people have to take actions that are against their own self-interest.
Sure. And people who are interested, actually back in episode, I had to look this up, episode 112, I talked to Nada Grunden, who had done a lot of lean work. She'd written a book about lean in healthcare. Her husband was a pilot. They were like personal friends with Captain Sullenberger. And she was a big advocate for the need for kind of reporting mechanisms and learning and safety culture that they that is sometimes brought from aviation. But think back to Sully in that plane and his co-pilot and all the passengers. You can't really error-proof against a bird strike unless you somehow have a design that's magically robust against that.
Right. And so the moral of the story there is that you cannot mistake-proof everything. And that goes back to kind of the psychology of errors. Things that are slips, things that are your intent is correct and your execution is flawed, you can mistake against those. But anything that takes deliberation or judgment, it becomes very difficult to mistake-proof those things. I'm constantly having people say, we need to mistake-proof that. And it's like, yeah, I can't help you.
Yeah. And I think, when you talk about near misses and that opportunity, Paul O'Neill, when he was CEO at Alcoa, he certainly advocated for zero employee harm. And part of that was the recognition and creating the culture that made it safe, if not required. But the thing is, again, making it safe for people to speak up about risks, near misses, minor injuries. That was the pathway to preventing fatalities.
Yeah, and that's pretty much all cultural kinds of things.
Right.
And what we see is that any place where you have that culture, it really helps. So, all of the work on crew resource management in aviation has been very helpful in terms of reducing problems. Once a warning light goes off in a plane or an alarm is sounded in a plane cockpit, their chances of fixing it properly is about 50-50, or at least that's what it was when they started the process.
Yeah.
And a lot of times everyone was so busy working the problem that no one flew the plane. And
right.
So
cognitive and cultural issues there. Yeah.
And so nowadays, when you have a warning light goes off, someone flies the plane, and that's all they do. The other people work the issues. And that's why Jeff Skiles was busy going through checklists on the Miracle on the Hudson.
Is the co-pilot.
And Sully was flying the plane.
And I'm pretty sure in the audio recordings, you hear like there's this procedural, my airplane, your airplane.
My plane.
Right? My plane. So it comes back to culture. And there's maybe the technical aspects of mistake proofing, but a lot of it is cultural. Just Culture, I think, is an amazing framework. I think of it as a healthcare framework that others could adopt in other industries. But it comes back to this question of, I think there's two different situations. There's the mistake of giving the patient the wrong medication or the wrong dose that leads to a death. And unfortunately, society still blames, punishes, or even sometimes prosecutes.
Yeah.
Versus a situation where there are cases where I would say this is clearly something you should prosecute, where people are intentionally murdering patients.
Right.
putting them out of their misery. Like, how would you mistake proof? Like, what checks and balances could you have to make sure somebody's not subtly murdering patients in a way that's hard to detect? I don't know.
Well, I'm not going to be, Perry Mason on this, or Murder She Wrote, or
Yeah, this
whatever.
got really dark. Sorry.
Yeah, so I think that you use every tool in the toolbox to try and sort this stuff out. And if sleuthing is required, that is something that we've done for a long time. And I think, if someone is doing that, they should be found and punished and perhaps prosecuted. I think that the just culture stuff really works for me in the sense that if you didn't intend to do harm,
Right.
you look at it differently than if you had a reason to believe you're doing harm. So my example is, if you drive to work and you're driving the speed limit and you get in a wreck, at some level, it's not really your fault. You can drive 10 or 15 miles over the speed limit and you're breaking the law, but you didn't think you were going to do harm. Probably understanding what was going on in your life that made you want to do that, or the fact that everybody does that, kind of changes the equation for me. Now, if you drive 100 miles an hour to work, that's not a reasonable thing to do.
Right. Or if you know that, if you know somebody is drunk and you let them drive anyway, or you are a bar who's overserved somebody, knowing that they're going to be driving, there are different levels of responsibility there. But I think a lot of times we're quick to oversimplify it, and in a lot of these healthcare error cases, find a scapegoat, or simple. We found the problem. We found the person who screwed up. They've been fired. It's not a problem anymore. But even back to instances of intentional intentional harm, or let's say the occasional, this is pretty rare. Like the surgeon who's known to be, let's say, so incompetent that they are really harming people, and others aren't speaking up about it. That becomes a cultural issue, and you say, well, now there starts to be some culpability on leaders of the organization. If you knew there was a problem and you didn't address it, or you stifled the communication channels that would have informed you, it becomes more than just an individual problem.
Yeah, it would be nice if we could just talk to the local surgical nurses, and when they say, don't use that doctor, they know what they're talking about. They're right there with them. They know what's going on. I tend to try to trust them a whole lot. And so, I really think it'd be great if all the surgical nurses say, yeah, I'd rather not work with that doctor. That's useful information. I don't know how you culturally allow that to get out, but it'd be great if we could.
And sometimes it comes out after the fact in the reporting about something. It was like, it was known, we spoke up, you didn't listen.
And so often organizations will need really compelling evidence to end someone's career in their hospital. And I kind of understand that. But in those cases where the evidence is all there and no one took action, it's troubling. It's really troubling.
Yeah. There's there's an expression that's been written about and even dramatized a little bit. Dr. Hodad, have you heard this?
I've not heard that.
This slang. So HODAD is an acronym that stands for Hands of Death and Destruction. And there's this balance, and I think just culture helps us figure out where, look, I'm all about saying most errors are caused by the system, but there are some outliers where they're either just so grossly incompetent or intentionally causing harm. Like there's a whole podcast and a TV series I can't bring myself to watch or listen to, called Dr. Death, a surgeon in Dallas who was really just maiming people, and it went on for a really long time. Now, if that's the rare exception, we need to make sure that that's addressed differently than quote unquote systemic errors. Right. It could happen to any surgeon.
So I think it's important when you do root cause analysis and you're looking at what's going wrong, that you almost never take a negative descriptor of a person as the root cause.
Right. Tell
But
me more. Yeah.
I also think that when you've ruled everything else out and you've got the data to show it, it's unconscionable not to act on it.
So one thing that frustrates me, I'd love to hear your reaction to it, is like, we might be making baby steps toward not blaming an individual and throwing them under the bus. But then I've heard this progression that I think only goes part way, where an organization will say, okay, well, it was a systemic problem. We're not firing someone. It was human error. What can you, there's nothing you can do about human error. I'm like, oh, that shouldn't be the end of the story, right?
Yeah, you're talking to the wrong person about that. Mistake proofing is all about that.
Yeah.
And if it's a judgment call, you should have other people looking at that judgment. And you should be rewarding differing opinions.
Mm-hmm.
You know, one of the problems is if everyone's responsible, nobody's responsible.
Mm-hmm.
And so the more people you have look at it, the less responsibility any one of them takes.
Yeah.
And what you need to do is see if you can figure out some structure that will keep the accountability for each and every individual, so that so if you can make it blind so they don't know what other people have said, all kinds of other things that will lead people to take it very seriously, that's worthwhile. Having 5 nurses check something is not a recipe for success.
Sure.
But with judgment, redundancy is really the only answer, because the normal mistake proofing process is not very good.
Well, so there's 2 levels of possible mistake. Back to and I will point people back to the episode of My Favorite Mistake 186, where I do get John's thoughts on definitions of like mistakes as bad decisions versus slip-ups. So if I'm going in for lower back surgery and they cut in the wrong place, that would be like a slip-up. They didn't intend to cut there. But then there's diagnostic decisions where 2.5, almost 3 years ago, I went to a surgeon where I had a really badly extruded disc that was pressing against a nerve. It was awful. And the first surgeon said, in his judgment, in his professional experience, you need surgery immediately or your foot and leg are going to be numb for the rest of your life. Well, not because I distrusted him, but I ended up going for a second opinion because, long story short, he said, well, if you have the surgery, which you need, you can't travel for 6 weeks. I'm like, okay, well, if I can't travel for 6 weeks, I need to have that surgery in Orlando because I need to be there with my wife at the time if I can't travel for 6 weeks. So the surgeon in Orlando had different judgment. He was younger, he had newer education. He showed me the journal articles that said, guess what? Outcomes are better if you wait and let the body try to heal itself first. So like, quote unquote mistake. I mean, there's a difference between a decision that the other surgeon's judgment would say isn't grounded in science versus doing the right thing the wrong way. That was a really long-winded way of trying to compare those types of mistakes.
Helping people not make errors in surgery is easier than than diagnosing the right surgery.
Yeah,
absolutely.
Preventing execution errors is easier.
Right. Execution errors are where mistake proofing thrives. Deliberation and decision in unstructured problems is where it's more difficult. We're starting to see this. We're seeing this move towards evidence-based medicine, and I think that's in the right direction. But yeah, even there, you're just codifying statistics to have it supplant personal judgment.
Yeah,
I think a lot of times that makes lots of sense in terms of kind of mistake-proofing personal judgment. But you'll always have those counterexamples.
Yeah, I mean, even about 10 years ago, Dr. Brent James, who is considered one of the leaders in the modern quality and patient safety movement, I saw him give a talk, and he said, for all the talk of evidence-based medicine, it probably applies in about 35% of cases across medicine. Like there are some really common, really well-known things, like a child with certain illness symptoms, like, okay, clear, possible, ear infection. Like, okay, there is absolutely evidence-based best practice for how to treat that. Me having this weird, mysterious lower back pain, not so straightforward.
Yeah, right. And of course, the APGAR score has changed medicine more than any other one thing.
What is that score?
The APGAR score is the score that you give a child when they're born.
Mm.
And you look at, there's a whole series of there's a rubric, if you will. I don't know what the clinical term is, but a list of things that you look at different aspects of how the child was born, and they get a rating. And the better the rating, in some sense, the healthier the child. And so the practice of giving birth and the medicine around that has changed dramatically since the 60s, if you will. Mm-hmm. And it's all because we had good metrics of what the outcome looks like. Probably has some side effects, and almost any mistake proofing you do will have some side effects. So, for example, the side effect in giving birth is there's so many more C-sections than there were before.
Yeah.
And
some hospitals are really working to reduce that.
Right. But that was driven by the fact that if you used a C-section, the APGAR score tended to be higher. And so any chance that it was going to impact the baby negatively, there was that much more impetus to not have a natural, vaginal birth. And so, yeah, all this stuff is all mixed together. And then we have to so we're trying to port things over from Toyota production system and Shingo to an environment where in a lot of ways it's very different.
Mm-hmm. And then part of what you point to, I think, is like side effects of metrics and targets and rewards, where, if cardiologists are being ranked, rated, compensated based on, post-op mortality rates, there's this dynamic of where they might choose to not take on the sickest patients.
Yeah.
Which is kind of a bad distortion of what the care should have been.
Which is why I'm a little skeptical, like they have health grades and things like that, where you look up your doctor and you say, is this doctor great or not great? And some of the best doctors may be those doctors who only do the hardest cases, mm-hmm. and lots of their patients die, but far fewer than expected. And so I'm not sure, in trying to create transparency, that we've got it right yet. So,
well, as another professor from statistics and quality fields, Dr. Donald Wheeler would say, statistics without context have no meaning, right? So if you look at mortality rates across hospitals, could be very misleading. There are these sort of mortality ratios of actual versus expected based on, smarter people than me figure that out. And, we have to be careful with that. So, as we wrap up here, again, we've been talking to John Grout, from Berry College. You can check out his website, mistakeproofing.com. And again, that PDF book that you can either get online or contact John to get is Mistake Proofing, the Design of Healthcare Processes. And kind of one last question I wanted to ask you, John. Looking at a book like that or getting education on mistake proofing, like what's the benefit in seeing examples to maybe in some cases copy versus developing a way of thinking and a process for developing mistake proofing?
So there was a guy at the VA who we were talking about this book, and he says, so is it a catalog or is it a catalyst?
Mm.
And it's both.
Yeah.
And so on the one hand, I think that examples are a catalog where you say, I'll take one of those. Mm-hmm. But there's a lot of other cases where you'll say, oh, so they did that in that industry. In my industry, it would look like this, and it would be something entirely different. Mm-hmm. And so I hope that it is both a catalog and a catalyst, and that you design it carefully, vet it thoroughly. It may have side effects, but if it does, those side effects may be far less than the side effect of not improving the system.
Mm-hmm. That's very well said. So I think we'll leave it at that as a final note. So John, this has been a lot of fun. I hope people also enjoyed, or if you haven't, go check out episode 186 of my favorite mistake. Lots to learn from John. I feel like we've just scratched the surface, but thank you for a great discussion and for sharing some of your knowledge here today.
I've enjoyed it very much.